All right, I guess we're going to get going again. So, how are y'all doing? It's good having you again. We're going to wrap up position and warning systems, and let's see what we've got here. Anti skid systems. All right. Um, what do we have here? Looks like we've got a few. Here's a summary of what level of instruction you should be receiving. You should be able to inspect service and check service speed and configuration warning systems, electrical brake controls, and anti skid systems. And the two specifics that I took out of our operating manual is you should know the general requirements for installing skid detectors, and you should also know the operating principles of hydraulic brake anti skid systems. I've got a few definitions up here on the screen. Well, let's go over them. Basically, anti skid system is an electro-hydraulic system in an aircraft's power brake system that senses the deceleration rate of every main landing gear wheel. So you accelerate and you decelerate. So if any wheel decelerates too rapidly, like it gets locked up, that indicates an impending skid. So pressure to that brake is released and the wheel stops decelerating. Pressure is then reapplied at a slightly lower value, which is common. You go into a skid, and most drivers' instincts are to hold on to the brakes. Excuse me. Um, you really have to release those brakes, which it kind of goes against your nature because you're sometimes skidding out of control. Hydroplaning, usually that happens when there's some water. It's a lot easier to skid if water's covering the runway. A dry runway, you're not going to skid as quickly, but water, yes. You apply the brakes, the wheels lock up, and the tires skid on the surface of the water in much the same way that a water ski rides on the surface. Hydroplaning develops enough heat in a tire to ruin it. So just because it's on the water doesn't necessarily mean that you're that it's good for the tire. It's 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 not. It's probably locked up, so you're going to basically drag a tire across the runway, which is going to you know um, ruin it. Is the words they use. All right, so that's a lot of talk. Early anti-skid systems. You do use a simple form of manual anti-skid control when driving on ice. For the most effective stomping, you pump the brakes. So you're basically releasing, at least you're not just holding down the brake. So you're pumping them back and forth. So and eventually you might grab something. They are applied only enough to slow the wheel, then released before the wheel decelerates enough to lock up. This same on and off type of operation was employed in some of the early aircraft anti skid systems. However, this method only works well when the control valves are capable of operating very quickly. And that was the part that did not make them work as well as we would like. And as you can see, there's a chart that the engineers, I'm sure, threw together to basically measure the rotational speed of the wheel. You can see here the wheel speed, and all of a sudden it decelerates rapidly to zero. So you can tell it's not rotating at all. So it decelerates to zero. And then and they're trying to correlate this with the brake pressure by putting the brake pressure on here, right at this point, which, let's see, where the lockup ends at the point D. So you're locked up here, the lockup stops, so you can basically at that point release brake pressure. And E, you're at full recovery. All right, so parts A, B, C, D, and E, and I guess the explanation over here goes into it. I do print off this presentation and include it in the D2L program, so right after this lecture you can actually review this. So I'm not going to read it all out. I think we went over in a fairly decent summary. Anything more, I think, would start to detract. We're just looking for a general understanding. This might be a little bit more than what you really need to worry about because it is not tested. But it's good to know it all anyway. So what do we have in the anti-skid system? We've got components. There's wheel speed sensors, which is off here on the upper left. Okay, they're labeled below. The wheel sensor, that goes in each of the wheels. A control unit in the middle, and that does not have to be near the wheels. And control valves for each of the brakes. So that's basically how the brake pressure is applied and not applied to the brakes, and it's controlled by a control unit. And the control unit gets its information from the sensor. So there has to be some sort of wheel speed sensor. I suppose there's other ways to measure the wheel speed. Similar to if you look at the timing chain or the on an automobile, you check the timing belt with a timing light. So I imagine there is a way to measure. That's the easiest way is to stick something actually in the wheel axis that spins around at the same rate, or at least it is pushed in one direction or the other on a resistor to be enough to tell you a signal. A valve that needs to act quickly enough. I guess that's what we have here on the right. All right, just some more ways of stating what we've already talked about. Here's a question. An anti-skid system is a hydraulic system, partially. An electro-hydraulic system, I like that the best because C is an electrical system. And the brake portion and the valves, that's hydraulics. And the wheel sensor, that's connected by wires, so that's electro. So electro and hydraulic. This looks like a true and false. An anti-skid system consists basically of three components: wheel speed sensors, control box, and control valves. Well, I don't know if I could have stated it much easier or much more clear. Yes, and if there is an oral question, that's a good answer for it right there. So I would certainly say that's true. what about the other part of it? An anti skid system is designed to apply enough force to operate just below the skid point. So I guess that chart does come in handy a little bit. But you might not need to chart it out just to be able to figure it out with the words that they're asking. Um, so you don't really want it to start working after you skid. So if you can ideally, uh, you know, fix the skid before it even happens, and therefore you are anti-skid rather than trying to fix a skid once it started, which would be more like de-skidding. So yes, that's a nice concept. Basically, the designers try to work those valves before the skid starts. All right, we're going to look a little bit at a wheel speed sensor. And I was right. Basically, it's a variable frequency AC current. Oh, I see. I forget exactly how these work. But basically, because this is revolving, you can actually turn that into a generator. And basically, that's what it is a generator. And it generates a variable AC form of electricity. The control unit converts the varying frequency AC into a DC signal voltage that is proportional to the frequency of the AC circuit. Okay. Um, I'll accept that at face value. I don't know whether I need to look at that closer. There is a conversion from AC to DC. Why at this point I couldn't tell you exactly why. It does look like the conversion does result in some sort of proportional DC voltage. Um, there's that look of the speed sensor again. You can kind of see the mechanism that would actually do the spinning. The DC wheel speed sensor does not require an AC-DC converter in the control unit because it generates a direct current proportional to wheel speed. The shaft of the armature is fitted with a blade driven by a bracket in the wheel hubcap and rotates with the wheel. Well, that would be the blade that's sticking out here, and that rotates with the wheel. Um, the generator output usually is in the range of 1 volt for every 10 miles per hour of wheel speed. And so you can see how it measures it. It produces a voltage that you can convert to what the rotation rate of each of the wheel is, which normally you measure in miles per hour. This is the wheel speed sensor and hubcap from a DC 1030 aircraft. Sometimes, if there's going to be a figure that I have or an illustration or something from at least the early textbooks, you're going to see it in an older presentation like this. The stator, and that's a generator term, there's a rotor and a stator, but the stator, stationary portion of an anti-skid wheel sensor, is mounted in the axle, and the rotor is coupled to the wheel hub spider that rotates with the wheel. Well, we figured that there was going to be some mechanism, since it's acting like a generator. There would probably be a rotor spinning, which induces a current into the stator, which is drawn off and used. In an anti-skid system, wheel skid is detected by, is it an electrical sensor, or a B, a discriminator, or C, a sudden rise in brake pressure? Well, not the best question here. Luckily, there's enough bad parts of it where we're unlikely to get it wrong, but we do know that they're not measuring brake pressure. At no point were we talking about the brake pressure. We were always looking at a current that was generated by a wheel sensor. So we like the word sensor, which is on A, and it is an electrical sensor. A discriminator, I think they throw some of this out just to see whether or not anybody bites, but no. And I'm sure there is a discriminator, but it's not a common item. That certainly doesn't fit in here. Now, if the wheel slows down faster than it should, the sensor sends a signal to the control box, and the hydraulic pressure on the brake in that wheel is released. At what point in the landing operation does normal skid control perform its function? You can see a lot of these are very similar. What was that last question? How do you detect it? It's a sensor. What are they asking here? At what point in the landing operation does normal skid control perform its function? A, when wheel rotation deceleration indicates an impending skid. Well, I certainly like that. That covers all the conditions. B, when wheel rotation indicates hydroplaning condition. Well, you're already locked up, so you're already kind of in a skid. So I still like impending better. C, anytime the wheel is rotating. In the landing operation. No, we haven't covered it yet, but once you get to a certain part where you ordinarily, if you're going 10 miles per hour, you don't have to worry about a skid. Well, maybe with a big aircraft like that, but basically anti-skid control is disabled once you get to a certain miles per hour. So C is not right. So it's obviously A. All right. The purpose of anti-skid generators is to, we already saw what the generators are. Those are kind of in the sensors. So we pretty much am going to be looking for something that aligns with that portion of the system. A, monitor hydraulic pressure applied to brakes. Again, they want to throw that pressure side of it to you. And with anti-skid, if you don't fully understand it, where an anti-skid generator fits into the equation, you might think it has something to do with applying a brake pressure. But no, that's not what the generators are for. That's more the valves. And they're just applying. They're not necessarily monitoring. I guess they are monitoring. B, indicate when a tire skid occurs. No, because it's already occurred. And C, measure wheel rotational speed and any speed changes. That's the best and cleanest answer. C. Yeah, nothing new here. Oral question. Where are the skid detectors located in an anti skid brake system? So, where are those skid detectors located? Um, well, that's going to be in the wheel, or probably more specifically in the wheel hub. So, it can, yeah, the wheel hub, I guess. It would have to be as direct in the middle as possible. Yes, in the center of the wheel hub. All right, so it seems like mostly they want to know an anti-skid here for position warning is more about the detectors portion of the system. So far, they haven't really said much about the control unit or the valves. Well, we don't have much to say about the control unit here either. Um, we're looking at the label here. If you can't see it, it says Goodyear Skid Control System. It has a type, a unit, an assembly serial, a spec, and a contract space to be filled out. And there's some etching on it. Looks like a part number, perhaps. This is the control unit. I know it doesn't look very smart, does it? And then the valve. Basically, you allow the fluid to flow to the brake, or you divert it, and basically the brake fluid. See if I'm going in what direction I'm going. I presume that uh, the system return manifold. All right, so let's see what it says here. Um, for normal operation, the valve serves only as a passage between the brake control valve and the debooster. So I see on this end there's a debooster, and on the other end there's the brake control valve. And then when the wheel speed sensor determines a skid is imminent, it directs anti-skid control valve to shut off flow to the debooster and vent debooster to system return manifold. So that's in effect what the valve does. So it's a little simpler operation. It doesn't really have any electrical parts. Um, that's apparent from this portion of the system. I should probably uh, modify that statement. That's not necessarily a true statement. So, but I don't plan on editing the video. So, catching it on the fly. How are we doing here? 23 minutes. All right. I'd say we're right on track. We mentioned deboosters. Technically, we divide. I don't know why they take anti-skid out of the other study of the landing gear and the wheels and the brakes and that whole system. It seems like it would go with that. For some reason, maybe because of the nature of the system, which isn't, although it's tied right in with the system. There's a line where we divide Airframe 1 and Airframe 2. And technically, debooster is on the Airframe 1 side of the line. But let's look at it anyway. Deboosters are installed between the power brake control valve and the brake cylinders to decrease the pressure and increase the volume of fluid going to the brakes. All right, so once you get past uh, the anti-skid valve, I guess you go to the booster, and that would be the one that actually applies the pressure to the brake. Am I getting that right? Uh, I may be developing some sort of a presentation for landing gear because it is so close to the airframe 2 portion. As a matter of fact, lately they've been adding landing gear to airframe 2. It's just that it throws the other side out of balance. So they try to keep the same volume of education divided evenly between the two sides. Um, but it's all in the airframe, so I do have to slow down and say we probably won't be asked about the boosters, but don't be too surprised. So basically, deboosters are to decrease the pressure and increase the volume of fluid going to the brakes. And they should have a second sentence where they're located. Throwing it all together makes it hard for you to see. Oh, well, I guess I'll talk about it a little bit more. Um, After saying we don't have to worry about it here, I'm going to talk to you another 3 or 4 minutes on it. Okay, high pressure fluid from the power brake control valve presses down on the small end of the piston. So here's the high pressure coming in from the top. So it presses down on the piston. And I don't really see the piston here. I see a ball. Large end of the piston forces fluid out to the brake wheel cylinder. That would be at the bottom. Oh, this whole mechanism is the piston. That kind of looks like a little high-rise skyscraper or something. So the high-pressure fluid is pushing this whole mechanism down and basically compressing the spring. Um, the ball is basically to prevent fluid from going the other way, I would presume. If leakage in the brake line should cause loss of fluid, the pin will force the ball off its seat, and the large end of the booster cylinder will be replenished with fluid. Okay, it's a little bit of a fail-safe there. If it goes down too low, this gets pushed off its seat so that you can still get sufficient brake fluid coming through. Otherwise, it had nowhere to go. So this gets pushed off the seat, and the high pressure brake fluid comes through where it looks like it's low pressure, but it'll turn it into high pressure. So that's kind of what a brake debooster valve does. It's kind of interesting. I don't cover them that much, so maybe I'm more interested in them than you are. A flapper valve. The flapper is over here. It looks like basically it tilts. The T tilts one way or the other, depending on the electricity from one side of the T to the other. It's lined up with a permanent magnet. So basically, by changing, you can. It's a hydraulic function. You can change the fluid from one side to another. This is and most of the hydraulic systems look pretty complex like this. If you may have already covered them, so it's just another fairly complex hydraulic system. You could study them a little closer, but let's see what we have to know about a flapper valve. It's a DC signal from the control unit energizes the coil on the armature. I see the coils there. And the movement of the flapper changes the pressure drop across the fixed orifices. All right, so more pressure depending on what side you're getting. Do we want more pressure or less pressure? Basically, the signal can change it. And the flapper valve moves extremely quick to be able to make that control valve work pretty quickly. More about a control valve. It uses a torque motor controlled flapper in the first stage of the valve to adjust pressure on a spool in the second stage of the valve to build or relieve pressure to the brake. So basically, in order to even speed it up even more, they've come up with another configuration. And what do we have here? I see the check valve. Is that what they're referring to? Is um, a torque motor controlled flapper in the first stage. Okay, here's the first stage valve, and here's the flapper, and I guess that's energized to turn one way or the other there. To either block one nozzle or to open the other nozzle. So that adjusts the pressure before it comes down to the second stage of the valve, where pressure on the brake is either it's going to be regulated much more careful down here. And I guess it is this little check valve that prevents it from one way or the other. All right. Just be aware that there may be two sections. You can see where it's divided. There's a faint line there. So the first stage and the second stage. I guess we have a lot of figures on the flapper valve. This one doesn't look terrible. At least we can kind of see it a little clearer. We can see when the pressure comes in on both sides as opposed to just one side. Do we need to look at this any closer? The A is when the flapper is centered between the nozzles. The pressure drop across orifice O1 and O2 are the same, resulting in output pressure of P1 and P2 are both get the same output, which looks like it would be the same input from the brake valve. But if there's a pressure drop on one side, you can see the brake valve is now going to just supply the one side. The P2 is where the pressure is. And that could be back into the reservoir. Here's two anti-skid control valves with the associated plumbing and wiring. I found this, so I figure I'd include it, but I don't know if that visually helps anything. These are the control valves. Basically, these must be brake fluid lines. So, and it does not appear that there is any electrical connections. Is there? I can't quite tell if that's what this is. Oh, there is plumbing and wiring. All right, so we have wiring that does go to the valves. Oh yeah, to basically to energize the coil one side or the other over here. So we need some wire. All right, sorry, I'll catch up. Here's a rack-mounted anti-skid control unit from an airliner. We've got a few of these in the shop to show you. But once you've seen one of these, you've seen them all. As far as studying what all the diagrams say on the front, it's not really going to help a lot. After a while, you'll know if there's a press to test. I mean, that's the most common button on one of these line replaceable units. This one here, I don't know. You'd have to get out the maintenance materials to tell you exactly what these dials are for. But we don't go into that type of detail. Just be aware. You learn enough about it, at least you're going to know what the unit's for. It's a control unit. It's sending it's getting a signal from wheel sensors, and it's sending out instructions to control units attached to the brakes. And it's sitting in the avionics bay, or the E&E, electrical and electronics. All right, in a brake anti-skid system, when an approaching skid is sensed, an electrical signal is sent to the skid control valve, which, what does it do? The wheel sensor tells you that a skid is imminent. What does the skid control valve uh, do? They're kind of skipping the, they're going right to the control valve. So what would it do? Um, so I'm not sure. Let's read the options. A, acts as a bypass for the debooster cylinders. B, relieves the hydraulic pressure on the brake. Or C, equalizes the hydraulic pressure on in adjacent brakes. Okay, adjacent brakes. Uh, well, number one, I can see why I included information about the debooster. I don't want you to think that that's what it is for, but I definitely want you to be aware of it because you're going to see the words, even though it's technically not in Airframe 2. So therefore, it's probably not the correct answer. Uh, so that might be one way of eliminating the option. Say debooster. Oh, that's Airframe 1. So not the best reason for discounting it because it's what is the electrical signal, which is the skid control valve. Is that acting as a bypass for the debooster cylinders? I think the debooster was acting as the bypass, wasn't it? No, it might be actually. That's actually not a bad answer the more I think about it. It's the bypass before the fluid gets to the debooster cylinders. That may be the right answer. I take that back. B, it relieves the hydraulic pressure on the brake. The skid control valve does do that, so I like that also. It certainly is simpler. Or C, it equalizes adjacent brakes. No, it does not do that. If one of the wheels is in a skid, it doesn't do anything with the other wheel. It just corrects that one wheel. So A and B are both decent answers. I think maybe I remembered it as being debooster as Airframe 1, but it might be. B is a simpler answer, and sometimes if you make it a little more complicated, like acting, bypass, debooster, cylinders, you're making it there's four complicated words there, as opposed to basically what does a skid control valve do? It relieves the hydraulic pressure on the brakes. So I gotta like B better. Take your time on some of these answers. You are given the equivalent of 2 minutes for each one, and some of them you're going to fly through because you know the answer. So you could probably the tougher ones you could spend 5-6 minutes on it if you need to. So what did we decide on? B? Yes. Does it say anything about the booster in the explanation? No, it just tells you what we already knew. The skid control valve relieves pressure on the brake. Which device in an anti-skid brake system would likely cause the brakes to fail to release when a skid developed? Now there's an interesting question. Who's the likely culprit? The brakes fail to release, so they're continuing to be locked up, and the skid had developed. So who's at fault? Could be which device in the anti-skid brake system would likely cause the brakes to fail to release? Well, it's unlikely to be the wheel sensor. That's basically continuing to spin or not spin. So that's going to be either a control valve or the control unit. Cause the brakes. So that's plural. So, if we have two sets of brakes, chances are we have two different valves. So even though one valve on one wheel stops, the valve on the other wheel, they both would have to fail. So I would tend to think that it's the control unit. No, it's a malfunctioning anti-skid valve. Okay, the brakes. I suppose even if it's on one wheel, because there's a few different brakes in there, we do say the brakes in wheel A. So I went by the plural, and what's that? That's an oral question. So when you are ready for your O&P exam, you're going to be reviewing the oral questions anyway. Um, and because we know you are, I've included a quiz so that you can actually uh, have a reason to study these oral questions ahead of time. Uh, since I don't want to have the instructor go through every single answer because you gave a short answer reply, which is probably the best way to do it. I've basically turned these into three option multiple choice. So that would be a malfunctioning anti-skid valve. B, I might say the control unit, which, or C, I could say the wheel speed sensor. And so you'd have to say which one is the correct answer. And certainly, if faced with it, you could say either or. They're not going to stop you. Well, it could be a malfunctioning anti-skid valve or the control unit itself if it's affecting all the wheels. And technically, it doesn't necessarily. The control unit could still be at fault even if it's just one wheel. But it does say most likely. So unless you have a lot of experience in the field, uh, most likely is probably a relative term. A locked wheel detector receives a signal from the squat switch, which indicates whether the aircraft is airborne, or on the ground. All right, we got to keep remembering. I mean, we're probably used to taxiing and you know getting ready to take off, where the wheels are actually on the ground. But what happens with all of a sudden the aircraft takes off? Uh, or you're lowering, more likely you're getting ready to land, so you're lowering your landing gear, and so the squat switch is in. Um, well, basically your wheels are down and locked, and the anti-skid system is not started by that because technically your wheels are not accelerating, so uh, they're not going to allow you to apply any brake pressure. So I guess that's a little different. So according to this, the squat switch is connected to the locked wheel detector in our, I guess it would be kind of part of our anti-skid system. So that indicates whether the aircraft is airborne or not. So certainly if you're airborne, we expect the wheels to not be accelerating. And therefore if if you're airborne, that prevents the brakes from being applied before touchdown, which I guess is another instinctive thing. I don't know. Just be aware of it, I guess. Control valve. This is we're still talking about the locked wheel detector. control control valve. On touchdown, the squat switch removes. Okay, here they're showing the squat switch on the ground or in the air. So now that now you do have locked wheel arming, and the wheel speed sensor is over here giving information into this unit, into this control valve. I'm sorry, into the control unit. Control valve is on the other side. Um, all right, so you can imagine what the question is going to be. Um, what arms the locked wheel detector? Probably because the squat switch is, this should say airborne over here. It does on the next one, air. All right, so that didn't make it that clear. Um, so basically, you do not have a connection here. Is that what they're trying to show us? All right, it is what it is. When a landing gear safety switch, another of many names for the squat switch or the wow switch or the weight on wheel switch, uh, when a landing gear safety switch on a main gear strut closes at liftoff, which system is deactivated? Okay, you're lifting off. You're going from on the ground to in the air. What system is going to be deactivated? Well, what have we been talking about all day? We've been talking about the anti-skid system. Um, Luckily, they didn't also give us the locked wheel. What do they call that? Locked wheel detector system. So it's clearly the anti-skid system. Don't even really. We're running out of time, so I'm not going to drag this out too much more. Anti-skid. Um, it's a landing gear safety switch, activates and deactivates the anti-skid system. Here they say weight is off the landing gear or the weight is on. So however it's wired. In the air, with the anti-skid armed, current cannot flow to the anti-skid control box because landing gear blank. A. Squat switch is open. B. Down and lock switch is open. Or C. Anti-skid valves are open. Okay, so why can't the anti-skid control box work when you're in the air? Is it because the landing gear switch is open? Now, if they also had an option D, squat switch is closed. We did see that's why that first slide where it was in the air, the system was not activated. So the squat switch would have to be open. So it is A. Down and lock, that has more to do with landing gear. And anti-skid valves are open. Well, that's not exactly has anything to do with current flow. So the squat switch is open. Yeah, you don't want to land with the brakes on. You're gonna already be start a little bit out of control because they're gonna lock right up. You almost have to let it set before you apply the brakes. So the squat switch will at least stop you until there is weight on the wheel, so you can apply them fairly quick. All right, it seems like a while ago that I talked about once you get down to like 10 miles per hour, the The skid detector and the modulator provide signals to the amplifier. So you have a skid detector and a modulator up here giving signals to the amplifier, which basically I'm not sure exactly why this is put here, but it when the airplane is on the ground and all wheels are rotating more than 20 miles per hour, the skid detector and the modulator provide signals for the amplifier. Is there a second part of this? Oh, okay, there it is. When the airplane is on the ground and all three wheels are rotating less than 20 miles per hour, the locked wheel arming circuit is inoperative and the pilot has full brake control for low speed taxiing and parking. Yeah, I guess it would be hard to taxi and park with your anti skid trying to mess with you, countermand your braking commands. Um, True and false. When the airplane is slowed below approximately 20 miles per hour, the anti skid system automatically deactivates to give the pilot full control of the brakes for maneuvering and parking. Almost verbatim what we just said, so that is true. Anti skid braking systems are generally armed by a centrifugal switch. We haven't seen anything like that at this point. B, a switch in the cockpit. Well, I kind of imagine you do kind of have a switch in the cockpit. Hopefully, that's not the best option. Or C, the rotation of the wheels above a certain speed. Uh, Trick question, isn't it? I guess I'm going with B. It's been years, but I seem to remember that being the correct answer. Uh, the rotation of the wheels above a certain speed, would that arm the anti-skid braking systems? Not necessarily. Normally, a squat switch would disarm the system, but to arm it to begin with, you'd have to have a switch in the cockpit. I mean, the pilot has to have the right to turn off the anti-skid. Okay, almost verbatim what we were just talking about. Here's a slide entitled AC and DC, the difference between the two. Um, it's the difference would be in the converter. So I guess if it's AC, it's converted to DC, which uh, which then follows all the way through to a signal to the control valve. So that's the big difference. Yes, if it's a DC wheel, which then, and I don't know, they didn't really explain how that would work. I imagine it has some sort of brush system or brushless. Um, so there's a converter here. Hopefully, there's not a question on this. A Boeing 737 anti skid control unit internal block diagram. I probably included this just because it was so colorful. There's a converter up there. So the transducer. So the first thing in that system is the converter also. Um, Basically, there is more into it before it goes down to the valve. A lot of nice words. The tweak test. Basically, you're kind of flicking the wheel speed sensor to see if you can apply the brakes or not, or seeing whether it applies and releases the brakes. So it's a quick little test that the technician can do. The two leads on the anti-skid control unit might be switched as a part of the troubleshooting procedure. So what's that? Switching with another unit or switching between each other? Okay, there is some switches in the cockpit. Here's what they look like. Anti-skid, inboard, outboard, on and off. There's your switches right there. I imagine if you do turn it off, the light's going to be on to remind you that it's in op. Auto brake. Okay. True, false. A warning lamp lights in the cockpit when the anti-skid system is turned off or if there is a system failure. Okay, that sounds like what I just said. I and it's almost like I reviewed it. That's true, and we saw where the light was. Even it says in op on it. The number one oral question for position warning systems, at least according to this publisher, is what unit in an anti-skid system generates the anti-skid warning signal? Well, there we use the word generates. So is that the generator, the wheel speed sensor? The control unit. Gee, I'm just not getting these correct, am I? What unit generates the warning signal? Um, this is debatable. Um, you'll notice in the section that's included, this this presentation, obviously, I can see from the formatting, is a one that's a little older. Um, it doesn't necessarily it doesn't keep up with all of the latest oral questions that we've been able to obtain and include that in your D2L module under oral questions. There's review materials. I would go by that to begin with. If there's other questions that weren't in the more the official questions, we do kind of include those, like here. And I guess, maybe when I was first studying this, I just accepted that as true. But now that I'm looking at it, I don't necessarily agree with this answer, but it's just me. But this answer is not official. These questions are not um, are are not published, or if they are, it's I don't know the history of these questions. Here's the second one. How is a pilot alerted that an anti-skid system is automatically returned to a manual brake system? So how is he alerted that the anti-skid system is turned off and now you have to manually brake? It's probably the light in the cockpit by a warning light. And what is the significance of an anti-skid warning? The warning light usually only comes on if the system is turned off, or I guess if it is malfunctioning. The system is off or has failed. All right, is this, no, we got another one. My apologies. We are going, we're going to be crossing the hour point, so I must be a little more long-winded with this one. So let me wrap it up. These type of questions I don't like. Which of the following functions does a skid control system perform? A or one, normal skid control. Sure. Normal braking. Um, 3, fail safe. Sure. 4, lock wheel skid control. Yes. 5, touchdown protection. I think it does that too. Takeoff protection. I think more touchdown. So what did I say? 1, 3, 4, and 5. Is that an answer? B? I'm going to take that. And here's the 757. Explore that on your own. And go ahead and review it. You can see somebody's in a skid there. All right. I appreciate you guys hanging with me. Uh, Congratulations on completing this lecture series on position and warning, and hope to see you in a future class. All right, you have a good day, and good luck to everyone. Goodbye.